Today we're going to travel back in time and look at the development of the atomic theory, also known as the history of the atom. We're going to look at uranium atoms magnified 3.5 million times by a tunneling microscope. Even under this very powerful microscope, the atoms look like blobs of energy. Today we have a theory on what an atom looks like due to the testing and the experiments done by great scientists of the past. Did you know that no one had ever seen an atom before the invention of the tunneling microscope in 1981? However, the existence of atoms is not a new idea. Atomic theory has been around for more than 2,000 years. Let's review what we already know about atoms. So what is an atom? It's the smallest particle into which an element can be divided. Atoms make up elements. Elements combine together to form compounds. All matter is made of elements or compounds. Atoms are often called the building blocks of matter. Let's review those definitions again. An atom is the smallest particle into which an element can be divided. Elements are substances that are made of atoms. Compounds are formed by elements combining together. Today we are talking about the atomic theory. So what is a theory? A theory is a unifying explanation for a broad range of hypotheses and observations that have been supported by testing. Let's travel back to ancient Greece, around 440 BC. We have a Greek philosopher named Democritus. Democritus imagined what would happen if you took a substance like a silver coin and cut it in half, and then cut it in half, and then cut it in half, and cut it in half, and again, and then again, and then again, and then again. Democritus thought that eventually he would end up with an uncuttable particle, a piece that could not be cut anymore. He called this uncuttable particle atomos. Atomos is the Greek word for atom. In the late 1700s, John Dalton, a British chemist and teacher, creates an atomic theory based on experiments. He had learned that elements combine in specific proportions based on mass to form compounds. In 1897, British scientist J.J. Thompson finds the electron in the atom. How did he do this? He used a cathode ray tube. A ray was shot through the tube, and he discovered that a positively charged plate would attract the beam inside. He called these particles in the beam corpuscles. Corpuscles are negatively charged particles in every atom. today we all know that we call those negatively charged particles in the atom electrons. He developed the plum pudding model. Basically, electrons and protons made up an atom, but the location for each was not known. So atoms were sort of soft blobs. Looking like this. Equal amounts of electrons and protons. So what is a model? A model is a representation of an object or system. It is a picture of what a theory explains. (1909) Ernest Rutherford was a student of Thompson. He tests Thompson's theory. He set up a gold foil experiment. He shot positive alpha particles through gold, and a sensor on the other side would know where they went. Most shot straight through the gold. Some did not. They would shoot right back at him. He had discovered the nucleus. He revised the atomic theory and described the atom as having a nucleus, a region that was tiny, extremely dense, and positively charged. The atom was made up mostly of empty space, and electrons traveled around the nucleus. Their exact arrangement could not be described. In 1913, Niels Bohr, a Danish scientist, worked with Rutherford. He suggested that electrons traveled around the nucleus in definite paths. Paths were located in levels at certain distances from the nucleus, and electrons could jump from level to level. Let's look at the current model of the atom. Schrödinger and Heisenberg work together, and they suggest that there are regions inside the atom where electrons are likely to be found. Their model suggested that Bohr was not quite right. Bohr had said that electrons traveled in definite paths. We know today that the atom has an electron cloud, and this is a region inside the atom where electrons are located. It's related to the paths described in Bohr's model. Here's a picture of what we know the modern-day atom to look like. So this sums up the atomic theory and what we know about the atom today, and how we came to know what we know about the atom today.